Hi everyone, thanks for joining me on Last Minute Maths, and in this video we're going to look at another Cambridge STEP paper question. This is a Step 1 paper and it's the 2014 specimen paper question 2. All right, if you want to look it up online. Before we begin, as always, your comments on the other videos have been very useful, very informative, so please do leave your questions, suggestions, comments below, and I'll be happy to reply to them and do any other videos that you might request. All right, so let's go into the question itself. All right, as you can see, there is a right angle triangle, okay, there, and the information they've given, I'm not going to read out the details, you can see what's going on, and you have two angles. The one that we're interested in is theta there, and I've labeled the other angle, angle APB, as alpha. All right. The part of the question that's important, we find that they're defining, right, x may be varied. All right. So this is variable. Okay. But h and d are constant. All right. Just to verify, that's what they've put in there. Okay. So in this triangle, we don't change the line A to C there, but A to P, this line does change. Okay. All of that one can change. Now, I want to illustrate something. The question is aiming for a value of x that maximizes theta. All right. Without looking at it too deeply, you could be forgiven for thinking that if you just make x as short as possible, right, then theta gets maximum. Okay, so that's x and that's theta. Yeah, sorry, not a very good theta. Compared to like that. Problem is that h and d, that line, the position of B, is remaining constant. It's not the whole angle that we are dealing with. It's the theta part. And if I now do the same thing, you will see, right, like that, and then like that. Theta will actually get smaller. Right? That part of the angle is going to get smaller, right, if I were to actually draw it accurately. So the question is not quite as obvious as some might think. There's a little bit more to it. All right, so we're going to start. The solution begins with the first bit of knowledge that you need to recall from A-level is the compound angle formula for tans, all right, where tan A plus B equals tan A plus tan B, all divided by 1 minus tan A times tan B, all right? So the formula there. If you like, it's something you can verify by setting tan A plus B equals sine of A plus B divided by cos of A plus B. And maybe I'll put it in at the end of the video as a little extra verification. Okay, so given that formula, I'm now going to substitute in my compound angle from the diagram. And I don't want to make you dizzy, but I might have to keep going back and forth to the diagram. All right, so I'm looking at the compound angle alpha plus theta. That one there. Okay, so straight on from that formula, tan alpha plus tan theta divided by 1 minus tan alpha times tan theta. Okay, from the diagram, and again, I'm going to slide up, so watch out. The tan of alpha plus theta is the opposite, AC, over the adjacent, which is AP. And that turns out to be h plus d over x. All right, so that's what we're using. And there we have that there. Okay, tan alpha plus theta is h plus d divided by x. And tan alpha, again verified very quickly, tan alpha is h divided by x. All right, and I'll put that there. Tan alpha is h over x. Okay, so that is verified there. Okay, so what we're effectively saying, therefore, is that tan alpha plus theta equals that derivation. This is your tan alpha here, and the tan theta we don't know. That's the very thing that we're trying to find. So we're starting with that formula there, okay, the one you see there. In order to simplify and get rid of the denominators on the right-hand side, I'm going to multiply top and bottom by x. All right, so basically you're just multiplying by 1. All right. Again, I'm going to assume some level of knowledge of the A-level further maths syllabus. So some of the things I'll state, other things I might leave out. But if I skip anything that you'd like to know more about, again, please do leave it in the comments. Right, coming back to the formula, h plus d over x simplifies to h plus x tan theta, you can see, and x minus h tan theta. All right, so numerator and denominator. Cross multiply, and we end up with h plus d times x minus h tan theta, and xh plus x squared tan theta. All right, so expand the whole thing out. All right, be careful, do not lose any terms when you do this. Be very, very methodical. If you're doing this type of question or exam, you need to be very methodical and go through everything term by term. Make sure you haven't lost anything. Make sure you haven't got an incorrect sign. Even I'm guilty of doing that, quite frequently, so have to check. All right, rearranging all of that, for example, xh goes out, and then we're collecting all the like terms, and we want to get, in this case, the dx on its own. All right, so rearranging everything, we get this statement here. All right, dx equals h squared plus dh plus x squared, all times tan theta. All right, so again, rearranging, very simple, tan theta on its own is dx over x squared plus h squared plus dh. Now, very, very important. This is dx, all right, is not a derivative. And for this reason, I actually think that the selection of letters in this question was poorly thought out. They could have used any letters for this, and they picked D for some reason. But here, dx is actually d times x. They're two lengths, not a derivative. All right, so make sure you understand that. And I'm just rewriting it in this form here, where it's x squared plus h times h plus d. Just simple factorization, nothing special. Now here we're going to recall two things about the tan graph. Okay, so if I just scribble it over here somewhere, remember that the graph is sort of like that. All right, we're looking at the range 0 to 90. All right, and in that range, the question tells us that theta is acute, so make sure you know that. And then in that range 0 to 90, tan theta is an increasing function, right? We know that, we can see that. And therefore, when theta is max, then tan theta must also be a maximum, all right? i.e. maximum within range, for the range that we're talking about. Okay. So what we want to do is to maximize the value. We want the maximum value of tan theta. So dx over x squared plus h times h plus d has to be maximum for tan theta to be maximum. All right. Now I've used the sort of different notation for d by dx normally. I've used the Greek delta form so that it doesn't get mixed up with dx. All right, so that thing there. Watch out, that is completely separate from the derivative. So this is a derivative. Okay, right. So what is the differential of this? Okay, we're going to use the quotient rule. If your function f equals u over v, then df, I don't know, call it x, I suppose. In this case, we are using x. It's going to be u v dash minus u dash v. Oh, have I written it the wrong way around? Whoops. Let's quickly get rid of that. I knew I was going to do something wrong there. I'll write it the way I'm used to writing it. And we've got, right, and v squared underneath. All right. So hopefully everybody's comfortable with that. All right. And so what we're doing here, this one, that one there, we've gotten from our derivative. So if I label this now, going back to my original, that is u, and that whole thing is v. All right. So this d here is u dash. That is simply the whole of v. Okay. And on this side, I've got, what have we got there? V dash and u. All right. And this one is v squared. So please note that that sort of tallies with what we have from there. Okay. Sorry about all the red lines, but you get the picture. You see what's going on there. Tidying that up, expanding the brackets, we get the following: dx squared plus d times h plus d minus 2dx squared again, and all over the original denominator. The denominator has not changed. All right, so that's the same. So remember, that is going to cancel with that, and we get dh times h plus d minus dx squared, and all over the original denominator, x squared plus h times h plus d in brackets, all squared. All right, let's not forget that bit. For this to be a maximum, all right, you've got the derivative equals 0. All right, again, you recall that turning points, minima and maxima, have a gradient of 0. Okay, in case you're not sure, whoops, gradient equals 0. All right, so it's either like that or like that. In this case, we know from the definition of the triangle that it has to be a maximum. So derivative equals 0. For the derivative 2 equals 0, the numerator must be 0. That's a condition. And the denominator must not be 0. So both conditions have to be satisfied. All right. And in this type of step question or a higher level maths question, you've got to demonstrate that you've validated both conditions and that both conditions are satisfied. Okay, so starting with the numerator, from the above there, dh times h plus d minus dx squared equals 0. Rearrange, you can get rid of the d's because we're multiplying by a factor and the whole thing equals 0, so d cancels out. And you're left with x squared equals h times h plus d. So logically, x must have a value that is plus minus square root of the product of h and h plus d. All right, so that's our main statement. Then we have to verify that the denominator, all right, is valid, that it does not go to 0 and make the whole thing an anomaly. All right, so if x equals plus minus square root of h times h plus d, then putting that in, replacing that for x squared, if you watch, so this thing actually goes to h plus h, oh, sorry, let's correct that, there you go, plus d times h, plus another h there, and that gives us the result here, which we know from the triangle, the original triangle, that h and d are constants, they're not 0. So these are non-zero given in question. All right, there we go. So that statement does not equal, that's valid, verified. So finally, we come to our actual solution, all right? And that is that x equals the positive root, okay, of h times h plus d. Positive because obviously, and I'm going to write obviously, but I'll state it anyway, x cannot be a negative length, all right? Okay, so bear that in mind. And that value of x gives you the maximum value of theta. All right, so that's the solution to that question. Now, a couple of notes. If you watched this far, this is not the most difficult of step questions. It is the second question in a step 1 paper. All right, so not the most difficult. However, there's lots of little matters of technique that you need to remember in this. I was going to, just before I finish the video, just quickly do the derivation of the tan a plus b. As I do this, anybody else who's been watching, if you want to switch off the video there, you've got what you needed, fine. Anybody else is interested in derivation, stay with me by all means, and I'll show you what's going on. All right, let's take a look. So what we have, we can do this. Okay, so using our compound angles for sine and cos. And again, this requires you to know the derivations and the different compound and multiple angle formulas throughout the trig part of the syllabus. All right, so sine b cos a, and cos a plus b becomes cos a cos b minus, now that's the trick that you need to remember, minus, all right, sine a sine b. Okay, and if we divide everything by What should we go for first? Let's see, cos b. Let's get rid of that one first. So we get sine a plus tan b cos a, and it's cos a minus sine a tan b again. All right. And then we divide everything by cos a, and we get tan a plus tan b over 1 minus tan a tan b. All right. Okay, that's just a little fun bit to end the video with. Scroll through if there's anything that you want to have explained further, then please, as I said, do leave it in the comments and I'll be happy to respond. And thank you very much for watching. Hope you'll join me for the next video. Do subscribe. There'll be more step questions coming along with the normal GCSE and A-level videos as always. Thank you again for watching. See you soon.